Okay, so we've done the notes together. You have that as your guide. But what does it look like when you have to do these all by yourself? We're going to do a few together. We're actually going to do all 4 of these together. All right? Now, I have 2 different colored pens, and I have 3 different colored highlighters, plus an extra highlighter for my greatest common factor if I happen to need it. So if you need to, pause the video and make sure you have those, but you should have them already from part 1. So let's take a look. We're actually going to start with number 52 because I want you to see something. Notice that with number 52, the first thing that we're going to do is we're going to pull out a greatest common factor. And if I look here, 4, 48, 140, these numbers are huge. Now, that's not bad, but I probably have a greatest common factor. Especially if this constant number is a really big number, you probably have something that you can factor out. So let's see, if I factor out a 4, then I have left over x squared plus 48, that gives me a 12, and then plus, let's see, this divided by 4. Well, 4 goes into 14 3 times, which gives me 12, left over of 2 and a 0, 5. Bam. So the number doesn't get tiny, but it definitely gets smaller than 140, okay? And remember, you're going to use your divisibility rules to figure out what your greatest common factor should be, and then you'll just divide it, okay? And you can divide it off to the side, or you can do it with a calculator if you need to, but you're going to divide by that greatest common factor to figure out what is left over inside, okay? So first thing I'm going to do is highlight this greatest common factor, and I'm going to take the rest of it, the other factor, the trinomial factor, and I'm going to write it down here, x squared plus 12x plus 35, and I'm lining up my middle term with this plus. Why? Because I know that whatever my 2 magic numbers are, they need to add together to be 12, or combine together to be 12. They also need to multiply together to be positive 35, because I have a positive 1 times positive 35. So that's what this top number should be. Now, let me think. If I take 35 and I factor it, I can do obviously 1 and 35. 2 doesn't go in. 3 doesn't go in. 4 doesn't go in. 5 will. So 5 times what? 8? 7. 5 times 7. I can make 12 with 5 and 7, no problem. If I have a positive 5 and a positive 7, they'll combine together to make 12, and they'll multiply together to make positive 35, which is exactly what I want. So now I'm going to take this middle term, and I'm going to split it up. So I'm going to do, let's see, move over a little bit so you can see. X squared, instead of plus 12, I'm going to do plus 5x and plus 7x. And my last term stays exactly the same, positive 35. Now I have group 1 and group 2, and I can factor just those 2 groups. So here and here, I'm going to factor out an x. And when I divide by x, that leaves me with x plus 5, because one of these will cancel and leave 1 left over, and both of these will cancel, leaving 5. Here I'm going to factor out a positive 7. When I divide by 7, I'll be left with, let's see, x plus 5. I check to see if my twins are there, and they are. So let's factor those out. And then if I factor these out, what's left over? X plus 7, sure. That's our other factor. Now I check to see, did I have a greatest common factor when I started? Oh, I sure did. So let me put that out front as well. Once all of your pieces are there, you're done. Okay? So let's take a look at another one. This time we're going to go backwards to number 51. Okay. So let's see. I'm going to have 3n squared minus 12n minus 15. So I need to combine together to make negative 12. And I need to multiply together to get, positive times a negative is a negative. 3 times 15 is 45. Okay, so let me think. If I have 45 and I factor this, well, obviously I can do 1 and 45. 2 does not go into this. 3 does not go into this. 4 does not go into this, but 5 does. 5 and 9. What else? 6 does not go into this. Let's see. Oh, you know what? 3 does go into it. 3 goes into 45 15 times. And look at that. That was my magic number I was looking for, because I can make 12 with 3 and 15. I want it to be a negative 12, so my big number is going to be negative. My small number is going to be positive. So my two magic numbers are positive 3 and negative 15. Okay? Now, I'm going to take my middle term and I'm going to split it up using my two magic numbers. So I'm going to have 3n squared plus 3n minus 15n minus 15. So I have group 1 and group 2. Here I can factor out 3 and 3, I can factor out a 3. N squared and n, I can factor out an n. So when I divide by 3n, what do I have left over? My 3's cancel, one of my n's cancel, and I'm left with 1 left over. Here my 3's cancel and my n cancel, which means I just have a plus 1. Okay, here I've got negative 15 and negative 15. Awesome, I'll go ahead and factor that out. And if I divide by negative 15, what do I have left? Well, it'll cancel here, leaving n. And negative divided by negative is a positive. 15 divided by 15 is 1. So there we go. My twins match. And so I'll factor them out. And then I have 3n minus 15 as my other one. Cool, I'm done, right? I hope that through this whole problem, you've been screaming at me, Miss Chiefy, stop! What did I forget to do? If you said I did not cancel or factor out my greatest common factor, then you're right. I didn't. Now, part of that was because I wanted you to see something, okay? Yes, you should always factor out your greatest common factor first, because it will make your numbers smaller and easier to work with. But even if you forget, or maybe you didn't realize that there was a greatest common factor, there's a few places where you can catch it. First, you could catch it here. If these two magic numbers end up having a common factor, then just go back and look and make sure. That's a kind of a red flag. Another thing you can look for. If you have, at the very end, you have factored it, but one of these factors, either one, has something in common. Look, 3n minus 15. Well, 3 is a common factor there, and it's pretty easy to see. So what you can do there is say, oh, 3 is in common here. Let me factor that out. Just like we would have done at the beginning, we can do it here too. I'm going to factor out a 3 from this one. And if I do that, left over I will have n, negative divided by positive is a negative, 15 divided by 3 is 5. So that takes care of that one. And then this is just n plus 1. So there's our final answer for there. Now, if you want, pause the video and try this again, but this time factor out the greatest common factor in the beginning. What you'll find is it'll end up being the same exact number, or the same exact factors, because that's what factoring is. It's just breaking it up into smaller parts. Okay? So that takes care of 51 and 52. Why don't you try 53 and 54, pause the video, and then come back when you're all done to see if you got it right. How'd you do? Are these the factor pairs that you got? If so, then you are ready to rock and roll, and you can finish the rest of the problems without any more support. I know you'll do great. The more practice you get, the better off you'll be for your test. But if you didn't get these two, or you're still a little fuzzy on how this works, go ahead and check out part 3 of this concept, where I'll work out even more examples for you to see.